Why is TensorFlow's tf.data package slowing down my code? I'm just learning to use TensorFlow's tf.data API, and I've found that it is slowing my code down a lot, measured in time per epoch. This is the opposite of what it's supposed to do, I thought. I wrote a simple linear regression program to test it out. tl.data, with 100,000 training data, tf.data, slows time per epoch down by about a factor of 10, if you're using full batch training. Worse if you use smaller batches. The opposite is true with 500 training data. My question, what is going on? Is my implementation flawed? Other sources I've read have tf.data improving speeds by about 30%. This outputs for me. Not using tf.data, with data size 500, input dimension 10 and training with a full batch, it took an average of 0.2024338289998013 seconds to run 10 epochs. Not using tf.data, with data size 100,000, input dimension 10 and training with a full batch, it took an average of 0.24317190400000644 seconds to run 10 epochs. Using tf.data, with data size 500, and input dimension 10, and training with batch size 50, it took an average of 0.095120888866661846 seconds to run 10 epochs. Using tf.data, with data size 500, and input dimension 10, and training with batch size 500, it took an average of 0.072869136000000844 seconds to run 10 epochs. Using tf.data, with data size 100,000, and input dimension 10, and training with batch size 50, it took an average of 4.421892363666605 seconds to run 10 epochs. Using tf.data, with data size 100,000, and input dimension 10, and training with batch size 100,000, it took an average of 2.25551975366667038 seconds to run 10 epochs. Edit, fixed an important issue that Fred Guth pointed out. It didn't much affect the results, though.
That is because you are comparing apples with bananas. On one hand, when using placeholders, you are providing a monolithic tensor as is. On the other hand, when using dataset, you are slicing the tensor into individual samples. This is very different. The equivalent of providing a monolithic placeholder tensor with a dataset pipeline is by using tf.data.dataset.from_tensors. When I use from_tensors in your example, I get similar, actually smaller, computation times than with placeholders. If you want to compare a more sophisticated pipeline using from_tensor_slices, you should use a fair comparison with placeholders. For example, shuffle your data. Add some pre-processing on your slices. I have no doubt you will observe the performance gain that makes people switch to this pipeline.
I wanted to test the dataset API, which seems to be really convenient for processing data. I did a lot of time testing about this API in CPU, GPU and multi-GPU way for small and large NN with different type of data. First thing, it seems to me that your code is okay. But I need to point that your NN is just one simple layer. Now, the dataset API is not suitable for your type of NN, but for NN with a lot more complexity. Why? For several reasons that I explain below, founded in my quest of understanding the dataset API. Firstly, in one hand the dataset API processes data each batch, whereas in the other hand data are pre-processed. Therefore, if it fits your RAM, you can save time by pre-processing the data. Here your data are just as simple. If you want to test what I am saying, try to find a really big dataset to process. Nevertheless, the dataset API can be tuned with prefetching data. You can take a look to this tutorial that explain really well why it is good to process data with prefetch. Secondly, in my quest of dataset API for multi-GPU training, I discovered that as far as I know the old pre-processing way is faster than dataset API for small neural network. You can verify that by creating a simple stackable RNN which take a sequence in input. You can try different size of stack. I have tested 1, 2, 10 and 20. You will see that, using the dataset API, on 1 GPU or on 4 GPUs, the time did not differ for small RNN stacks, 1, 2 and 5. To summarize, the dataset API is suitable for neural network that have data that can't be pre-processed. Depending on your task, it may be more convenient to pre-process data, for example if you want to tweak your NN in order to improve it. I agree that the dataset API is really cool for batch, padding and also convenient for shuffling large amount of data, but it's also not suitable for multi-GPU training.
First, you are recreating the dataset unnecessarily. Data_set equals tf.data.dataset.from_tensor_slices training_inputs, training_labels. Create the dataset prior to the loop and change the regress underscore with _tf.data input signature to use dataset instead of training_inputs and training_labels. Second, the problem here is that many batches of size 50 or even 500 are too small to compensate the cost of tf.data building latency. You should increase the mini batch size. Interestingly, you did so with a mini batch of size 100,000, but then maybe it is too big. I am not certain of this. I think it would need more tests. There are a couple of things you could try. 1. Increase the mini batch size to something like 10,000 and see if you get an improvement. 2. Change your pipeline to use an iterator. Example.
One possible thing you are missing is a prefetch. Add a prefetch of 1 at the end of your data pipeline like so. Adding a prefetch of 1 at the end of your dataset pipeline means you try and fetch one batch of data while training is happening. This way you won't be waiting around while the batch is prepared. It should be ready to go as soon as each training iteration is done.
If you want to see more, please consider subscribing.